Hey, what is going on, class? Welcome to another Algebra 2 video. Today we're going to be talking about exponent rules. Exponent rules. So, kind of the first thing that's important is we need to define what is an exponent. Definition. An exponent or power. These are synonyms. Exponent or power is a shorthand for defining the multiplication of a value times itself, and I'm going to use this phrasing n times. Okay, definition: an exponent or a power is a shorthand for defining the multiplication of a value times itself n times. That might not mean anything to you in that formal sense, but it's good that you start seeing these formal definitions of the terms that you've used. Like exponents are something that you've seen for years. You've been working with the ever so famous PEMDAS, where you've got parentheses. This is hard to spell down. Parentheses, exponents, multiplication. Some of these words are too long. Division, addition, and subtraction. That we've been working with PEMDAS for a long time. It's this middle part, it's the exponent. But this would be kind of the formal definition that if I were being asked to write a math textbook, this is probably how I would define it. So hopefully by learning some of these formal definitions, it helps you in the future where you're reading other formal definitions and you get the opportunity to go, okay, now I know what that word means. So let's take a look at an example. If I have x times x times x times x, well, this kind of fits into, so we have a value x, and we're multiplying it by itself. So x times x times x times x. And we're doing that, what we say is n times. So here, this is n. And in this case, you just count. How many things are there? There are 4 n's. Stop scrolling. There are 4 n's. So we would rewrite this and say that this is x to the 4th power. We do this little superscript. It's above the script line. So this is a superscript because it's not touching this baseline that we use for writing, which subsequently means, so let's do a little annotating here. So this is our exponent or power. And this thing here is our base because it is touching our baseline that we write on. So kind of you have a little bit of a knowledge of what an exponent is. Hopefully this is something that's just kind of kicking back into gear some stuff that you've already learned. But let's go ahead and let's take a look at some of our rules. So rule number 1 is, what if we have x to the a times x to the b? So I'm going to work through this slowly at first, and then we'll work into doing this a little quicker. So let's think about an example. If I have x squared times x cubed, well, what I really have, kind of going back to this style, is that I have x times x squared times x times x times x, my x cubed. So using this example and this kind of formal definition, it's n times So how many times do we count up x here? Well, we have 1, 2, 3, 4, 5. So we get x to the 5th. Now, I want you to practice these. Go through and do some problems like this from your homework, where you see something that looks like this. So x to something, some power, times x to a different power. Go through and try a few problems like that, and kind of see if you notice a pattern. So I'll give you a chance to pause the video and you can go do that. But for us, we have a rule, because let's think about, well, what is 5? Like if I were to say, can you write 5 as 2 something 3? Think about that, 10 seconds. So hopefully you're sitting there and you're like, yeah, 5 is 2 plus 3. So let's think about, how can we generalize that? Well, the new power is going to be the 2 powers we were given added together. So if we see multiplication between two exponents, we're going to add the powers. Something to note here. If you have x to the a times y to the a, you cannot simplify that. It is as simple as it gets, written like this, because you have two different bases. So keep that in mind as you're working through problems like this. Okay, let's scroll down. I'm not going to be able to get all the rules on one page, but I will do my best. So rule number 2 is, well, what happens if I have x to the a raised to another power? So I have a power to a power is what we call this. A power to a power. What do I do here? Well, let's think about it. What does this really mean? So let's say I have x to the 4th squared. Well, that means I have x times x times x times x squared, which that's still not as simple as we can make it, because what is squaring something? Well, squaring something is multiplying it by itself. So here we have x times 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 x. Let's count how many x's we have. Well, we have a group of 4 times a group of 4. So we have 4 plus 4 here. So we have x to the 8th. Now, let's think about, how do we get 8 from 4 and 2? We multiply it. So our rule here is that if we have a power to a power, x to the a, parentheses, raised to the b, then we get x to the a times b. This is where we're multiplying. All right, rule number 3. And maybe at this point, this one's going to be kind of a, you either know these or you don't. And hopefully these are the nice ones where you're like, okay, those first two, kind of hard. Those might be new to you. Hopefully these other two just make sense. If I have x to the first power, what do I get? Well, let's think about it. If I have 3 to the first power, let's think about it. And all the time that you've worked on exponents in Algebra 1, did you ever see anything raised to the first power very often? Think about in this class so far. You have dealt with things raised to the first power every single day that you've shown up to class. Yet you've never seen it written. Well, in mathematics, if you see something like this, and you're like, okay, I've seen it every day, but it's never been explicitly written, what that probably tells you is that it's redundant. It doesn't make a difference if you write it. That it's more of a, hey, this is a fact, just ignore it. And the reason for that is because mathematicians are lazy by nature. Our goal is to find the next big problem, find a solution to it, which means we can't be stuck on easier problems. So anytime you see something, because this is just saying you have 3 times itself one time. So anything to the first power is just itself. Now, rule number 4, by the end of this, and it'll be a question I pose to you at the end, you should be able to figure it out of why it's true, but for right now, I'm just going to say this one's an easy one. If you see this, I want it to be instinctual. X to the 0 is 1. Anything to the 0 power is 1. So if you see 1,517,293 to the 0, that whole thing is 1. Instinctual, every time. 3x to the 0 is 1. Y to the 0 is 1. It doesn't matter what that thing is. You could have some giant statement here. Some huge, the biggest math equation you've ever seen in your life, with parentheses around it to the 0, is 1. Biggest equation you've seen in there. So that one's easy. I want it to, something to the 0, 1, you scream it. It's out of you. Okay, got those first 4 rules. Let's keep going. Rule number 5. Now this one is more of a don't do this based on another rule. So we're going to start with the positive rule, and then we're going to kind of get this negative rule from it. So if you have x times y to the a, well, let's think about that. What is that? So let's say that it's 3x to the third. Well, let's think about that. We have 3x times 3x times 3x. And now let's think about it. Obviously, we couldn't combine 3 and x. We can't simplify that at all. That's as simple as it gets. So 3's can only interact with 3's, and x's can only interact with x's. So let's realign this. 3 times 3 times 3 times x times x times x. And now let's use our rules. Well, the exponent is going to be 3. We have 3 3's and 3 x's. So 3 cubed x cubed. Cubed is the same or equivalent, that's what this 3 lines mean, to power of 3. Same thing if you've ever seen squared, that's equivalent to a 2. Now, this is not incorrect, but it's not right either. This is not finished. You're not done simplifying it because we know what 3 cubed is, or at least we can figure it out because that's 3 times 3 times 3. What is 3 times 3? Just one time. 3 times 3 is 9, and 9 times 3 is 27. X cubed. That would be our final answer. But what do we do looking at this step here? Well, we said that x times y to the a is x to the a times y to the a. And then you can simplify it from there. Now, this next one, like I said, is a rule based on this one that is not like these others. These others so far have been, hey, do this. This next rule is more of a do not do this, so much so that I'm going to do it in bright red. Rule number, I don't feel like that's bright enough. Maybe that's a better red. Oh yeah, that's a better red for rule 6. Rule 6. If you have x plus y to the a, it is not x to the a plus y to the a. Not true. Never true. Do not do this. It is so hard to continue writing in all caps. In fact, I want you to say with me, read this out loud. I don't care where you're at, read it. If there is addition or subtraction in the parentheses, do not distribute the power. Say it out loud. I want you to repeat it 2 or 3 times. That's how important this rule is. Do not distribute the power if there is addition or subtraction in the parentheses. Just multiplication, distribute to your heart's content. If there is addition or subtraction, do not do it. This is so wrong that whatever you do on your quiz, so the quiz we've taken so far was out of 15. If I see this on the page, you will get a 2 out of 15 to mark that 1 means that you showed up, you took the quiz, but you knew absolutely nothing. I will always give you a 1. If you put this on the page, I will give you a 2 because it is so wrong that we need to mark it and we need to learn from it because it is going to hose you as you go down the line if you do this. So don't do it. Now, moving on from that one, because that's a negative rule, and I don't like negative rules. I like positive rules. What do we do and why do we do it? Let's look at what happens if you have x, whoops, I'm changing the way I'm writing things, so I'm sorry. Rule number 7. If you have x to the negative a. Well, this one is a little tougher to think about when we're dealing with it because it's kind of dependent on another rule. And that other rule is dependent on this fact. And it's like, where do you start? So you have to accept one of these, and they kind of work together to show that they're true. So let's think about if you have, I'm going to start with, let's just do 2, because binary is a great thing to start with. What's 2 to the 0 power? Hopefully you were screaming it instantly. It's 1. Okay, 2 to the first power. Hopefully it's just as instinctual. 2, it's itself. What's 2 squared? 4. 2 cubed? 8. 2 to the fourth, we'll just go one more time, 16. Let's think about what are we doing every time? Well, we're taking and actually, I'm going to do it down here. We're multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2. Now think about for a moment, what do we have to do to go from 16 to 8? What are we multiplying by? Take 10 seconds, think about it. So maybe your instinct was to say, okay, we're dividing by 2, but how are we multiplying? Whenever you're dividing by something, so in this case, we're dividing by 2. Well, division by 2 is the same, it's equivalent to multiplying by the reciprocal. So we're multiplying by 1 over 2, the fraction 1 divided by 2. So we're multiplying by 1/2. Multiplying by 1/2. Multiplying by 1/2. And multiplying by 1/2. So now I want you to think about What happens if we have 2 to the negative 1? Well, we have this nice pattern here. We're multiplying by 1/2, multiplying by 1/2, multiplying by 1/2, multiplying by 1/2 as we take this power down 1. So we're going down 1 from the 0 power, so we're going to multiply by 1/2. What is 1 times 1/2? Well, 1 times anything is that thing. So we have 1/2 here. Let's take it a step further. We're going to multiply 1/2 by 1/2. We have 1/2 times 1/2. And if you're struggling with fractions, don't worry. I'm going to post a video talking about those as well. 1/2 times 1/2, we just multiply straight across. 1 times 1 is 1. 2 times 2 is 4. So we get 1/4 here. So really what we're doing is we're saying, okay, x to the negative a is 1 divided by x to the a. Because isn't 4 just 2 squared? But we're just flipping it. We're putting it on the bottom of the fraction. Now, with this allows us to build the last rule. Rule number 8. And that is, okay, what if we have x to the a divided by x to the b? So let's look at an example. If we have x to the 5th divided by x to the 7th. There's a few different ways of going about this. I'm going to think about it, in my opinion, the more fun way. Let's expand this out. We have x times x times x times x times x divided by x times x times x times x times x times x times x. So what we want to do is we want to think about, okay, if we have a fraction, we can break it up. So like we could have two fractions here. We could have x divided by x times x times x times x times x over 6x's. Like this. We could do that. So let's play a game of war. We got the North and the South, and they're lined up. We're going old school, not guerrilla warfare. We're doing line infantry warfare. And they go to battle. And essentially, for those of you who don't know what line warfare is, infantry warfare, is you march in a straight line, you come together, and you pull up and you shoot. And let's say that all these people have perfect aim and they all are just shooting straight ahead of them. So you have here the first two guys are lined up, these two here. They fire, they hit each other. So we're down 1. These two are lined up, they fire and hit each other. That's a 1. It's a wash. Both sides lost 1. Lost another, and another. But these two on the end fired to nothing. They shot straight ahead and there was nothing there, so they didn't hit anything. But they also didn't get hit, so they're safe. So all that's left on the end is we have 1 on the top because all of these canceled out to make a 1. And we have x times x, or 1 over x squared. So that's one way to think about it. If you're like, you know what, I just find it fun to pull out a red pen and just scribble on the page really hard. Yeah, do that. This works. There are times where I'm just in the mood to use this method. This method that we call the war method. That works. Another way to think about this, though, is, well, we already have a rule, rule number 1, for if we're multiplying things. And we said earlier, in the last example, that when you are dividing by something, it's just multiplying by the reciprocal. So we could also say, using my other example color, we have x to the 5th times 1 over x to the 7th. Let's think about it. We have this other rule up here that we can use to translate this. All of these rules are just a translation. It is allowing us to say, okay, I have this, which means I have this. So we could rewrite this as being x to the fifth times x to the, it was positive on the bottom, so when we move it up to the top of a fraction, it becomes negative. X to the negative seventh. So then, using rule number 1, we have x to the fifth minus 7, or plus negative 7. 5 minus 7 is negative 2, or 1 over x squared. We get the same answer here. So we can say that our rule is x to the a divided by x to the b is equal to x to the a minus b. So here are your exponent rules. Make sure, write them down. I'm going to add one more thing here. Do it in my orange color. This is a saying that kind of helps with rule number 7 that I want to make sure that I get while it's on the screen. If the power is negative, then you must flip it over the fraction line and make the power positive. So if you have this little sentence here, use it. It's a command. So if you have x to the negative fifth, well, flip it over the fraction because everything is over 1. So flip it over the fraction, you get 1 over x to the positive 5. You also get, what if you have 1 over y to the negative 2? It's on the wrong side of a fraction. Flip it up. You get y squared over 1. So make sure, if any of these rules don't make sense, come in and talk to me. We'll work through some different ways of thinking about it. But these need to be second nature. You need to just see these rules and know, this is what I do. So make sure, come in and ask questions if you need to. Make sure you get the homework done for this stuff. This is days 1 through 3. Those will be accepted all the way up until next Monday. So you have the whole weekend to work on them. But don't wait. Come in and talk to me today, tomorrow. Do it before you leave for the weekend. That way I can give you some help. Otherwise, you can just look on the Delta Math and it will show you exactly how to do the problems. So, hope you're having a great day, and I will see you all in your class period.